Hey KTI scientists, you're about to dive into a very cool abbreviation which I actually brought up, which is called C.O.A.T.S. That's C-O-A.T.S. And you're about to learn more next on KTI Science. I'm TeamG, science editor for KTI Science. The big part about C.O.A.T.S. is a very good science explanation. But what does it stand for? C.O.A.T.S. is always a because when you use C.O.A.T.S., you first compose or conduct the experiment. That's the first part. The second part for C.O.A.T.S. is to observe what is happening. The A stands for ask what is happening. Needless to say, you need to figure out what is happening, or you can ask questions of what is happening in the experiment itself. The T is very important. That means you can take notes about what is happening, or you can jot down what is happening in each segment. And the S stands for summarize what happened. And that is what we're going to be learning about today in KTI Science. That's because you first have to figure out what is going to happen in an experiment itself. So I'm going to take you on a very cool adventure. And you're about to figure out what I'm going to do in this experiment itself, because I'm a real scientist. Take a beaker like this. What's inside? The first part on your left-hand side is nitroglycerin, which is that greeny stuff that actually looks like nitrogen for short. What you see on the right is destructive bombs. But it is gonna be more destructive, and it can actually virtually go through anything and just explode. First, you're going to conduct the experiment. To do this, you use the eraser tool and erase part of the walls. But for now, it's just one wall, which you see right over here. Now you're going to observe. Did anything happen? Well, of course something did. The nitroglycerin actually disappeared in a fiery substance. That's because this red chemical is very strong and is a very strong solid, needless to say. Now, ask yourself, how did this happen? How did the nitroglycerin turn into a fiery substance suddenly? To get your answer, you can replay it, or you can just reconduct the experiment together. And just like that, the nitroglycerin explodes and turns into a fiery substance. That's because nitroglycerin is radioactive to a destructive bomb. Now, you're going to take virtual notes. What happened is that the nitroglycerin actually reacted to the destructive bomb, and then it actually exploded into a fiery substance. Only the nitroglycerin exploded into a fiery substance. Now, the last thing is to summarize. You can summarize by using your knowledge or just replaying the whole thing altogether. What we saw in the nitroglycerin is that when we put it in a flow, it all turns into a fiery substance. When it touched the destructive bomb, it actually turned into a fiery substance. Only the nitroglycerin turned into a fiery substance. What happened is that the destructive bomb is a very radioactive element and is pretty strong. Now, let's take another using that scenario. Now let's say we have a scenario like this. What are inside of these? First, the first one on the top left you see is 2 pieces of water. One is carbonated water and the other is just water. And it has oil on top. The next one that you see on the top right is just soap. And at the bottom, you see 3 things. One is an ignition cord, C4, and nitroglycerin. First, let's conduct the experiment. Let's see what happens. That's where the observe part comes in. Is anything happening? Well, the water mixed together to get a new piece of water, which is just carbonated water, and is actually going through the nitroglycerin, and the oil is trying to trap the steam so that it doesn't get on fire. And as for the soap, what we saw is that it actually stretched. That's because it was trying to become a liquid. Needless to say, it is going to become a solid when we mix it together. That's where the asking part comes in. First, ask yourself, what is going to happen when we mix it together? Is anything happening? Well, when we mix the soap part together, the whole part just turned into carbonated water, and the soap is actually shrinking. That's because it's trying to take in that carbonated water. And how is the oil trapping the steam? The steam part is actually a gas, whilst the oil is a very strong solid. But it's actually a liquid. That's because the oil is more dense than smoke or steam. Now, let's see what happens when we take some heat. Do you see what is happening? What just happened? The nitroglycerin and the steam reacted, so did the oil to form some gas, and even some oxygen to release. And as for the soap, it exploded and some had turned into a solid, whilst the soap at the bottom is still a liquid. But the whole thing is just gas. So therefore, we have conducted the C.O.A.T.S experiment. Now, let's take the last scenario, and this time, you're going to process what is going to happen. Take a scenario like this. Are you going to ask what is happening? Are you going to observe what is happening? First, conduct the experiment. Now, you are going to observe what is happening. Therefore, you are going to be the scientist, and I'll try to conduct the experiment myself. Now let's see what happens when I cut the bottom off. You are going to ask yourself what is happening. Once you've done that, you can now take notes, either physical or virtual notes. And finally, you are going to summarize what is happening. Or you can summarize by using your virtual or physical notes about what just happened. And therefore, you, my KTI scientists, have now conducted the C.O.A.T.S experiment by using the C.O.A.T.S abbreviation method. And that, my KTI scientists, is how you conduct the C.O.A.T.S experiment.